In 8.4, there are two major sections that we've already covered. We covered some stuff in 1.4, and we've already covered some stuff in 7.2. So you're going to see some of the stuff that you've seen before. This stuff, I love it when we get to go back and see some things we did before and then just take it up one little notch. Instead of doing stuff we did in 1.4, we might have to throw in some variables with it. That's something we haven't done. So we're not just doing what we did in 1.4, but we're going to add the next step with it. Keep in mind, in 1.4 notes, we wrote down these notes. If there is a radical, that is the only type of number that has an invisible 2 inside that little v. If you do not see a number inside, it means it's a square root, and a square root means that you have to have two factors. I say that because sometimes we're going to be dealing with third roots and fourth roots in this worksheet. When we simplify radicals, don't forget, break things down and circle your groups about how many factors can break out, and only one factor breaks out per circled group. When we multiply them, insides multiply insides, outsides multiply outsides. Keep that in mind. Every now and then you may want to do things with exponential form and use your rules from 8.1. It's up to you. But the thing that I really need to highlight to you is this paragraph, because we have different rules for adding and subtracting radicals than we do for multiplying them. When we multiply them, this is what we do. But when we add or subtract them, we have to remember that we can only add radicals that have the same index and the same radicands. Let me translate that for you. We can only add or subtract radicals that have the same root and the same inside of the root. Meaning, I can only add square roots of 4 with other square roots of 4. I can only add third roots of 4 with other third roots of 4. Do not add a square root of 2 plus a square root of 7. It does not work. I'll tell you why. Square root of 2 plus the square root of 7 have the same index, but they don't have the same radicands. You can't put those together. It would just be square root of 2 plus square root of 7. But if it was the square root of 2 plus 7 square root of 2, you have 1 square root of 2 plus 7 square root of 2, it would equal 8 square root of 2. You add the numbers in front or subtract the numbers in front. If you have the number 2 and you were trying to add root 7, you can't put them together because you can only put root 7s together with other root 7s. This would just be 3 plus root 7. You would just leave it like that. Just so you know. With that being said, the last thing we have to do is rationalize. If you need reminders, you can go back to the 7.2 notes. It's about multiplying. I have one example for you that we're going to do together. But let's go ahead and get into some examples. This is number 3 on your worksheet. If you have number 3 on your worksheet and you want to do this with me, you are welcome to do so. When you have this radical symbol and there's nothing in this corner, you know that there's an invisible 2. It's the only thing in math that has an invisible 2. What that invisible 2 means, you have to have 2 factors to break out. Everything else you can do after this is just like we did at 1.4. 2 times 25, 5 times 5. That's how I usually break it down. And sometimes, if I need to, I break down m to the third into m times n because there's 3 factors of m. As soon as I break it apart, I kind of like cross it off because I don't need it anymore. And then I'm going to simplify looking for 2 factors that are the same. If there are 2 factors that are the same, I circle it. 5 times 5 is 25. The square root of 25 is 5. But I can just go like this, and a 5 can break out. Only one factor per circled group breaks out. Cross that off. The 5 does nothing to the 2. The 5 is multiplying this radical. I look at the m's, and since I need 2 factors, I can circle 2 of the m's, go like this, and an m can pop out. I cross it off. I cross off the circled group. One of these m's is left inside. Just like the n doesn't have a second n, so it stays inside. What's inside the radical stays inside the radical. The 2 stays inside, the m stays inside, and the n stays inside. They don't have a pair to break out. But what did break out was the 5 and the m. That is multiplying the radical, and this is what your answer is. Your answer is 5m times the square root of 2mn. The answers are going to look really, in my opinion, ugly. They don't come out nice and whole. There's these radicals. Some things are inside, some things are outside. Not everything breaks out, and they're just going to check to see if you know what you're doing. Any questions on 3? Then let's go to something that has a third root, number 7. This is a third root of 40d to the 8th. First thing I do is just like the other ones, I start breaking things down. I take the 40, I say 2 times 20 is 40, 2 times 10, 2 times 5, and I break these things apart into its primary prime numbers. If you want to, you can break apart d to the 8th. Eventually, you'll get good enough that you can do this in your head, that there are 8 factors of d. But I usually write it like this: d times d times d, and then times d times d times d times d times d. 1, 2, 3, 4, 5, 6, 7, 8 of them. And I organize them in groups of 3 just so that I have it ready for this problem. I need 3 factors to break out. That's what a third root means. Something multiplied by itself 3 times. And look it, I have 3 of these 2's. I can circle 3 of these. And for every group that's circled, 1 of them can break out. That's because the cube root of 8 is 2. There is a 5. It's still inside. It doesn't have 2 other factors, so it's going to stay inside. But then I have 3 factors of d and another 3 factors of d. The 2 d's get to pop out. But then these 2 don't have 3 factors. They have to stay inside. So I have 2d times d. I put those together. It's 2d squared because you have 2 of them. This is a third root. It stays the third root of. What's left inside is the 5 and the d times d. 5d squared. You put them back together when they don't have the partners. Now, some of you have really, let's just say, interesting handwriting. Let's just say it's interesting handwriting. Please make sure that when you are giving your final answer on any quiz or test that you are clear that the square belongs to the d and that the third root belongs to the radical. If you are a messy writer, I don't want you to think that the 3 and the 2 are next to each other. I put a deliberate space in there so I could be clear to the teacher or whoever's grading my test that those aren't the same thing. Okay? Number 14. I'm multiplying. Because I'm multiplying, outside numbers multiply outside numbers. 12 multiplies this number here. It's an invisible 1. 12 times 1 is 12. Inside numbers, I'm going to break this one apart to 3 times 7. I'm going to break the 56 apart to 7 times 8. And break the 8 apart to 2 times 2 times 2. I'm going to break the A down into A times A. The B down into B times B times B times B times B because there's 5 factors of B. Same thing over here. There's 3 A's multiplying. There are 3 B's multiplying each other over there. But because this is inside and because this is inside, they are both inside. You can find pairs from both of those when we're multiplying them. So this 7 that's here, if it has a pair with the 7 that's on the inside over here, you can put them together. I can circle the 7 and the 7, and that 7 gets to pop out. I can circle the 2 and the 2, and the 2 gets to pop out over here with the 12 times 7 times 2. I get to pull out the A times A. There's an A. Cross that off. I'm going to cross them off when I'm done just so I don't get confused. I'm going to pull out this B and this B. B times B. Over here, I get to pull out another A. I get to pull out another B. And then let me see. There's no more A's there. There's one A there. I have a B here and a B there. We can put those together. Pull out another B as well. I think the hard part is staying organized so you know what has come out and what's still inside. 12 times 7 times 2. Let's see. 24 times 7 is 28. 14, 15, 16. 168. So I'm seeing 168 on the outside. A squared on the outside. I have 1, 2, 3, 4 factors of B multiplying. B to the 4th on the outside. And then everything else must be on the inside. Square root of 3 is on the inside. Nothing there, nothing there, nothing there. A 2 on the inside. That multiplies the 3. And an A on the inside. So my final answer is this. 168 A squared B to the 4th times the square root of 6A. That's an ugly, ugly looking answer. But it's correct. So they've really amplified the question. It should not be that hard for you. It just should be, do you know how to stay organized with your work? I have 3 more examples and then we'll be done. Number 15. Square root of 3 plus the square root of 3. You have one square root of 3 plus another square root of 3. When you're adding them, they have to be the same. Square root of 3 plus another square root of 3 is 2 square root of 3. The root 3 does not change when you're adding or subtracting. Think of it like 1x plus another x is 2x. It stays the same. Very similar to that. But number 17 is different because you cannot add a root 7 with the root 63. They're not the same radicand. So instead, what you have to do here is think, can I break it down? Can I simplify it a little bit? Isn't 7 times 9 63? And doesn't the 9 break down? So if so, you're going to have to look for your square root, your pair, to pop out a number like we just did and get a 3 root 7. You'll leave this one alone. And then what you can do is do 2 root 7 plus 3 root 7. 2 root 7 plus 3 root 7 is 5 root 7, which is your final answer for number 17. Simplify it first to combine like terms. And the last example is number 25. It says rationalize and simplify. Sometimes you're going to just rationalize right off the bat. The notes for those are in 7.4. But if it says simplify, sometimes simplifying is easier to do when you start off. For example, since they're both inside the square root, You can simplify 20 over 15 by dividing by 5. So if you can simplify or reduce, that will make your problem a whole lot easier. It's easier to deal with root 4 over root 3 than it is dealing with root 20 over root 15. I know what the square root of 4 is. That's the same thing as 2 over root 3, because the square root of 4 is 2. Or there's a pair of 2's that can pop out, right? That's the same idea. But it says to rationalize, and in our notes we wrote rationalizing means multiply by the same radical in the denominator to the bottom and the top of our fraction. Technically, we're multiplying by the number 1 because root 3 divided by root 3 is 1. But what this will do is it will give us a pair of insides that are the same, which pops out a 3 in bottom, and on top creates this 2 root 3 on top. It's a way for us to rationalize. Our final answer for number 25 is 2 root 3 over 3.